System design. I'm sure you have heard of this word. What is the first impression that you got when you heard this word first time? Or another scenario, if you were hearing this word first time through this video, let's pause video for a minute and see what is the first thing that is coming to your mind. And system design, obviously, in terms of software system design. When I heard of this word first time, first impression was that this concept is something which is for someone who has pretty good amount of experience in the industry, whose role is to architect, design the system end to end. Only they should understand it, and it is for someone who has pretty good amount of experience, 3 4 5 6 years, senior software engineer or architect. It is only for them. If I'm just starting my career, or I have 1-2 years of experience, and in my day-to-day job I'm not interacting with the end-to-end system, because in the company, whatever company I have been working for, this one, I have assigned a module, a team is there, and I'm working for that, and my life is good. I don't have to understand what is happening end to end, other teams and all that. Okay. And this, why am I saying that? Everyone shares its own experience, right? So this was my first expression when I heard about this system design. And another very important thing also, like, it's very difficult to understand. From quite a time, I have been learning about system design, its concept. When it comes to system design, you have to understand different use cases in the industry. You don't have to limit with the company that you are working for. You have to explore the use cases. You have to see what are the applications that you are using and how they are working internally. What is that good thing that making them good? If I talk about some example, like it's Hotstar, live cricket streaming, big billion days on the e-commerce site, Netflix, video streaming sites. Okay, you see the scale that they are working on, right? And how well they are able to handle these amount of traffic. If that curiosity is in you, system design is for you. And if you have come across, you cross that line that it is very difficult, it is for those who are experienced, it is only for those who are architecting the system. If you have come after that line, you crossed that line and you understood it, so you will reap the benefit of understanding this system design. Okay, so I have been learning system design from quite a time. So by this video and more upcoming video, I'm going to organize those things and share it with you guys, and it will help me also groom myself more. I have been learning research papers, engineering blogs. I have been learning other system designs, like YouTube, Instagram, Facebook, many system designs. So it's been quite a time, and if I try to recall that how much I have learned, so by this document I have tried to summarize that thing, and whatever next am I going to cover. So just yesterday I was sitting and was trying to recall that what are the things that come when it comes to system design. So I was thinking, how can I organize this one? So the first thing that came to mind, that when am I getting a URL, let's say youtube.com, I got this URL, let's say this is the URL that I got, right? When I'm hitting this on the browser, what is happening behind the scene? Okay, so whatever is happening behind this, if I'm able to track that, that's all about system design. Okay, so I got this URL. If you see the concepts, like this is the browser. What is this browser that you are seeing? Do you know actually what is this? What is the internal? How it is able to take care? What is the structure of the URL? What is DNS resolution? What is proxy, forward, reverse? What is API gateway, firewalls? These are the things that you are seeing on your screen, these are the things that help your request. When you are hitting this request, these concepts are helping to serve the request and serve the content in my screen, in your screen. Okay, so the video that I'm recording, uploading it on YouTube, and you are watching it through YouTube, how it is streaming and all those things, transactions, caching, CDN, web services, message queues, distributed system, Merkle tree, consistent hashing, big data, LLM, generative AI, deployment strategies, and all these systems that I have to understand to get the complete understanding about this one. So I'm going to upload the detailed, like this is the just introductory video, first video where I am setting the roadmap. In coming up videos from now on, this along with the other content that is available on this channel, so parallelly this series will be going on where I will be uploading from time to time. So let's say from a month now, I have completed all these videos, all these concepts I have uploaded it, and you have spent next 2 months or 1 month to understand these. So, and let's go 1 month after that, what will happen? Will you be able to recall everything that is in here? Because I tell you, whatever I have learned, it is not everything that I have documented here, because I have not noted it down. There is no a single list or thing. So because if you have memorized something, understood something, and you are not able to relate in real life, it's very difficult difficult to recall and note that down. Okay, and the same thing is going to happen with most of you also. You will learn it, you will pass the interview, you will clear the interview, and if you're not using or experiencing it in day-to-day life, you will forget it. So now I want to take you to your school days when you were learning first concept. Let's take an example of the periodic table in the chemistry, where you have to memorize chemical elements, their atomic number, atomic weight, and many more things. So what teacher suggested, they suggested if you memorize it, you will forget it easily actually. But if you try to map these with something which is happening around you, if you can map those things, it will be very difficult to forget that. Same thing we have to do with the system design things. Whatever concept we are learning here, we have to map it with something that is happening around. And nowadays, it is when you wake up in the morning, during the day, there is not a single place that you won't interact with these concepts. If you are just curious about things and try to relate it. And this also does not mean that every time you keep questioning everything, but it's as an engineer and as a software engineer, I should be able to understand that how things are working. If I'm like I'm around various stuff like mobile apps, WhatsApp, Facebook, Instagram, YouTube, Netflix, Prime Video, everything is there. And if I got this understanding, I should be in a shape that I'll be able to design a system like that if there is a need. So if we are on that shape, we are questioning it. So whenever you was watching cricket live streaming, when the live viewers are increasing and you are able to understand the intricacies of the internet, like how application might be scaling, how streaming is happening, just watching the cricket and just keep thinking in your mind and how it is happening. This will solve the problem, and you will be able to understand it from the bottom of it. Okay, and you will be able to relate it, you will be able to apply it any of the use cases that is in your company or any applications that you are working on. That's what the target. So next 5-10 minutes I'm going to take your time, and I will try to walk through a request that is a request from start to end, and see how many concepts from here we will be able to map there. Okay, so let's start. So let's say I got the URL of youtube.com. okay, and first thing is my browser. This is the URL. I entered it. What is the first thing that will happen? So let's try to do that. So here I am the user. Okay, and I got the URL. This is the browser here. this can be browser, this can be mobile app also, where I have installed some app on my device. Okay, browser and mobile also is possible. In the browser, I have entered that URL youtube.com. What is the first thing that will happen? So I have clicked enter. First thing, it will go to the DNS resolution, because this youtube.com is the name of the website, but internally with it is whatever content am I seeing here, it is stored on some computer system that is on the network, and it is serving that content to me. So how to identify a computer? The address of that, IP address and port is there. So DNS resolution helps us to get the IP address of that. And when I got the IP address, first it will get the DNS resolution, it will get the IP address, and when it got the IP address, it will hit that individual IP address where our content is there. Okay, so the second arrow will be this one. What call it, like, let's say call it web server, where front-end contents are there, like static website pages, HTMLs are there. This web server is there, it is hitting this one, it got that one, and inside when it got that address, I got this youtube.com, and it's just not that inside that page, where if you recall the structure of the HTML, it has links and network calls for other application. Further, it has network calls to different APIs and servers, right? Different services actually. So it will further call to complete that page, it will further make call to different n number of services there. So first call it will make to identify the user, what that user is there. So it's very high level, so just try to understand the functionality here. So let's say there is a user management application is there. Okay, user management service is there, which is taking care of the login functionality and all sort of thing. Okay, and the second is like if we are talking about the video, so content storage will be there, content management will be there, and along with the content management service, there will be recommendation thing. What am I liking, what am I not liking, based on that it will be serving those contents. Okay, these individual services will be there down the line. So this web server, on a plain term, if I say as a layman term, it has to remember all addresses of all these services, and this is just example of 3 services that I have taken. So our web server have to remember all these, have to note all the server addresses, right? But that is not practically possible. That is where in between API gateway comes into picture here. Not this one, let's take this. This is where API gateway comes into picture. If you are able to recall it, like if you are able to understand it, how am I uncovering the different system design concepts here, like DNS resolution, web server, and the one thing has come up here with the problem. We have got the solution, how it is solved. Like this, noting down every individual server is difficult. That is why API gateway comes into picture. With API gateway, every functionality is registered. It kind of works as an orchestrator, our API gateway. Okay, and in here, if our web server is asking for the user management, API gateway is not doing in itself anything, but it will delegate that functionality to the individual components that it has. And similarly, there will be a number of functionalities. Now let's go deep dive into a single service, right? And because there is huge amount of requests coming at the same time, it's not that only few amount of requests are there. There are huge amount of, like, you can see the scale, how much YouTube is used. So if there is a single computer system is there, they have certain configuration in terms of RAM, capacity, CPU, whatever they have, there will be a limit that how much it can handle. So there will be replica of this one, multiple instances of this one. I have to place n number of services based on the requirement to handle the same sort of functionality. Okay, same sort of functionality as the need be there, that will be able to handle the same thing to do the user management. So that is where the concept of stateful and stateless services comes into picture. And user management is there, so definitely there will be database into picture. All right, so it will be interacting with the database obviously. And when we say the database, there can be SQL database, no SQL database is there. Just I'm talking about databases. Time series database is there. So which one is applicable in which case? That's a whole lot of concept and whole lot of thing to understand that in terms of databases. But you see how database came into picture. Now coming back to this one, when we have this n number of services to do the same functionality, how API gateway will know each of these instances? Because based on, there will be times when YouTube uses like this user management functionality is used a lot, and there will be time it is not used that much. So I don't want my resources to sit idle, to be wasteful, and whenever there is a need, I want them to be coming up, and when there is not need, I want them to go down. That is what is known as scalability, up scaling and down scaling. So how API gateway will keep track of those new instances that are coming up and the existing instances that are going down, how it will be able to recall that. That is where the concept of two concepts, load balancer and service registry, service discovery comes into picture. So all these new instances via service registry and discovery will register itself with a single load balancer. Load balancer is also an instance. It is running. It has a specific IP address and it has a specific port where it is running. And all these instances that are there, they will register themselves with the load balancer with the help of registry and discovery. So now API gateway has to know only this one. Okay, it does not have to know the individual instances of the user management, but if behind user management, all the services, there will set a single load balancer that API gateway will know, and load balancer will take care of the routing the request to different instances that are there based on different criterias. That is where internals of load balancer algorithms like round robin way, response time, weighted one, a number of things are there that will come into picture. Same thing will happen with the content management and recommendation also. There will be a setting a load balancer, registry discovery will be there, recommendation also will be there in that way only. And if we go deep into the load balancer, there is a client side load balancer, server side load balancer will come into picture, but the purpose will be same, distributing the load among available instances that are there. So we got this understanding, like load balancer and API gateway, how they are coming into picture, and understanding this, we got to know about scalability also. That is how it makes sure that our application is available all the time. So availability is yet another important term. And this user management, before serving it is not that it can have all the business logic. It will be further calling other services as well. Like it can have another service, that is fraud detection systems are there to check if there is any fraud or not. That will happen entirely on the backend, but it will be calling that system. So this will be calling further n number of services, and these services, when we are talking about, all of them are sitting behind a load balancer, and service registry and discovery is in the picture. Okay, so when it is calling it, so might be cases that it is not able to respond within a agreed time. That is where SLAs come into picture. When we talk about SLAs in terms of response time, you see, you might have seen the numbers 99.9999% availability, different nines. We have to understand that as well. What is that SLA, what is that availability numbers? And when it is calling, I should not be waiting all the time indefinitely. There should be kind of some tripping, kind of, if I directly take that term, circuit breaker kind of thing. So if it is failing temporarily, next call should be success. But if it is failing all the time, so our other services should not fail, because first time it can fail, but I don't want my all users to be failing. So that circuit breaker will keep that state, and if it is failing all the time, it will not make the call to this at all, and will handle it accordingly with the default scenarios that is there, and it will have its fallback mechanism and will call some other service. So that cascading failure, that in this distributed systems, again one new keyword, that distributed system, one service is failing, that will not cause the entire system to be failed. It will contain that to that failure only. Content management and all sort of thing won't fail in that case. So we covered circuit breaker also, resiliency also, scalability and all sort of thing, how it is coming into picture. Okay, now let's go deep further down the line. So by this amount of services, by this amount of requests that is coming up, and this huge amount of volume data that is being created on regular basis, on daily basis, system is also, if I search on this YouTube, you might have noticed, if you are watching a particular movie, let's say you are watching love movies, you will get the recommendation of love movies only. If you are watching movies of particular actor, you will get the recommendation of that particular actor only. Most of the time, not all the time, most of the time you will be getting that one. So how the system is able to understand you, how it is able to understand your choice, your taste, and it is able to recommend that. That is where big data comes into picture. That is where big data analytics systems comes into picture. Where it is able to analyze huge amount of data that is there and able to predict the behavior. So in terms of this one, big data analysis is there. So other terms like machine learning is coming into picture, where it is being used to analyze the user behavior and serve that content as per the taste of the user, right? And nowadays when we have this huge amount of data that is being created, so if I have to search a specific thing on the Google, on the internet, I go there, search it, I will get a number of websites that I have to go and analyze that and see which website is best for me. Like if I have to search system design, best sources of system design courses, right? If I see, I get the ads also, sponsored content, these things are there, and n number of other websites that are there that I have to go through it. I will if I am a newcomer, completely new, I have to go to each and every one and see which one is good for me, and it will take a quite good amount of time, because there is huge data available on the internet. It's very difficult to curate that one. And since chat GPT came into picture, right, from 1-2 years, past 1 year, if I go and ask same thing from chat GPT, let's do that. What is the difference between this search and this search that I do? It is exactly recommending me that what I have to do to get learning about this system design courses it has given me. If I ask it, give me plan to learn the above concept. I'm copying it, the same thing. It will give me the plan, week 1, 2, 3, online course overview, book reading, all sort of thing. It is going to give me the curated response that might be, that I'll be able to follow one by one. Let's say if I give the same thing here, it won't be able to understand anything, right? So what was the previous search that I made? But here it is able to do that. So that's what the difference has made since the onset of the chat GPT. When we talk about chat GPT, these are generative AI. This is what we call the generative artificial intelligence. It is like some expert is sitting behind the screen, and whatever I'm asking, whatever discussion am I trying to do, it is able to understand that, and it is able to interact with me. It is way different from the search that we do. So how it is possible? Because there is big data, machine learning is coming into picture, huge amount of data is being created, and generative AI is the next thing that is coming. So I have to understand that as well. Large language models, how it is working behind the scene. If I have just that curiosity and able to understand that, I'll be able to do that. So with this one, with this very, very, very high level, again I will say it's not the complete, it's very high level. It's at very high level here. If I see one, see this is how I'll be able to, front end things are there, and all sort of databases are there. And if databases are there, there is some amount transactions, different transaction technologies are there. Transaction is happening, I have to make sure data is consistent, it is not lost. Many things are coming into picture. When it is a distributed system, I have different different instances are there, right? And there are cases when I just have to as an user, I just have to command it that hey there, you just perform it in some other time, but I do not need response from you immediately. Let's say the way that I get the user notifications, right? So the order management things are happening, I get the order success, but not, email is not delivered immediately, but eventually sometime it is delivered. So those, how those are delivered, right? For those things, message queues come into picture. Message queues, what we call asynchronous communication, comes into picture. When message queues are there, Kafka, RabbitMQ, these concepts come into picture, and we have to understand that as well. And when we have all these of distributed things happening, different nodes are there. So in those nodes, there are high chances of failure that I have stored my content on a single node, and there is high chance that that can go down, and how the system will make sure that data is available even if that node is going down. So that will replicate to other nodes, right? And how the system will know that any node is going down and any new node is being added if there is high demand of nodes, high demand of requirement, no, I need those. How it is able to handle that? There are failures of node in terms of temporary failure, the permanent failures, how system is able to heal automatically. Different concepts are there, and if this is you are understanding, it's like hinted handoff, consistent hashing, Merkle tree is there, generative AI, and this we understand. We took the word like use the keywords till now here. So if let's say all of these are running properly, I have built it, they are serving. So behind the scene, they have to be deployed somewhere, right? That is where deployment strategies come into picture, and I have to decide whether a physical data center is good for me or I have to move to cloud. So there are both the options are there. Nowadays cloud is very popular, so physical data center becomes very costly, clouds are cost effective, and I can get started with a click of button. So that is where cloud is there. And if we further go down in the deployment side only, there are CI/CD, containers, clouds comes into picture. When I have built these codes, maintainability comes into picture. So code quality, observability, performance monitoring, and knowing the SLA numbers, I have talked about it already in this one, why it is important to know. And I have I'm not sure that I have put everything here. There are more things that are coming into this list that we all have to understand, and all the details I'm going to publish it in coming time. Along with these concepts, unless we understand the real life application that I told at the start of the video, how they are working, they won't hold any value. So we have to understand the existing system data like book my show, messengers like WhatsApp, e-commerce, YouTube, Instagram, URL sorting, how they are working and how these concepts are helping them to perform at such a scale. Design patterns are there, solid, gang of 4 design patterns, common patterns in cloud system, common patterns used in distributed system. All of this we will understand, but the way things we uncover is going to help us keep this in our mind for longer period of time, and I don't have to memorize it. I just have to understand that, relate it with the real life, and see the magic happening then, right? It will give a different kind of confidence in you when you will learn about these one. If you are curious and want to learn these concepts along with me, do subscribe the channel. Let's collaborate on the comment section. Connect me on the LinkedIn. We can discuss more about it, and you can suggest me the next topic that you want. I'll be able to upload. That will help me a lot to put these things into like to make things more realistic actually, if it is in a discussion mode. So don't, if you have any sort of question, don't hesitate to put that in the comment section or connect it on the LinkedIn or Twitter. I have put the link in the description and the channel description. It's already there. So I hope to see you in the next video. Till then, take care. Bye bye.